Hi guys, so we're starting a new unit. This is pretty similar to the one we did last week. We're actually going to use a lot of the same things. This section is specifically on triangle proportionality theorem. It might actually say side splitter notes in your worksheet that you have. It should be pretty easy for today. A lot of you guys are missing class today because you're not feeling well, so thoughts go out to you guys. Hopefully you start feeling better. I know a lot of people are getting sick. I had the flu last week, so hopefully you all are resting up, and we'll be back to school in no time. So let's get started. All right, so formatting's a little wonky on here, but really what you need to know is the section up top. If a line is parallel to one side of a triangle, if a line parallel to one side of a triangle, intersects the other two sides, then it divides it proportionally. So proportionally, remember, means fraction equals fraction. Or you can think of two equivalent fractions. Either way works. But that really is an important word for you guys to know. We worked with proportions a ton last week. Also, important thing to know, right here and right here, those little triangles mean parallel. So does this symbol here, although it's really hard to see. If you can't tell, looks like this. It looks like double L's basically. But both of those mean parallel. So good things to kind of keep tucked in the back of your brain. So let's take a look at this actually in action. I always kind of think of these as rafters in the attic of your house. Especially when you look at this picture, this one really looks like the rafters that you see up in the corner of your roof, and then you've got the parallel beams that go across to secure everything. So that's what it kind of makes me think of with this. So really what we want to do is set up things consistently. It doesn't matter if you do top over bottom equals top over bottom, or left over right equals left over right, as long as you are consistent. Okay, and that's kind of what the picture here did. Sorry, I keep bouncing back and forth. I keep forgetting about stuff I wanted to talk about. So if you look at this proportion right here, this is kind of the example they gave with the theorem. You've got RT, which is, we're going to call the top side, a little t there for top, over TQ, right here. We'll say that's the bottom side, is proportional to RU, again, another top side, over US, another bottom side. So top over bottom, top over bottom. We're keeping consistent like I talked about. So here, obviously I have to include X. Okay, my X looks a little weird. Okay, and we're going to say that this is the left side. Okay, that means X is proportional to its right side. I know because I got these little arrows here. Those make my parallel sides. Okay, well, if I'm going to do left over right, that means my second proportion has to also be left over right. So again, left over right. That's how I set up my proportion. Now, you could have done right over left equals right over left. You could have done top over bottom equals top over bottom. So you could have set up 32 over X equals 16 over 12. Those would have also worked. Okay, but as long as you're saying consistent, like I said. Now, two ways you can knock this guy out. A lot of you guys might have just automatically looked at this and said cross multiply, which is cool. That works. So we'll even set that up. We have 16x. Oh, goodness. I don't remember what this was in my head from earlier. I think it was 384. Make sure to double check the math on that. I'm not entirely sure. My mental math's a little poor, but I'm pretty sure it's 384. Divide by 16 on both sides. I believe, let me check my math on here. 384 divided by 16. Whoopsies. That's not correct. 384 divided by 16. There we go, 24. All right, and feel free to check that on yours as well. I'm pretty sure that's the right answer, so I think we're good on that. Okay, now some of you might have actually noticed another way you could do this. you wouldn't even probably need a calculator if you've got some good mental math if you did notice this route. So I'm going to rewind and backtrack a little bit. Undo all the marks that I made. Okay, now take a look at the fractions we've got. What do you notice about those two numbers? Hopefully that'll kind of kick something off in your brain. How do you get from 16 to 32? Well, you double it. If you get some good mental math. Well, if you got to double that side, whatever you do to one side, got to do the other side. So if I double 12, automatically I already get that x is 24. So two ways to do this problem. You still have to set up a proportion. You can either cross multiply or use mental math if the problem works out that way. And you can figure that out. Okay. Pause here, try the next two examples, and then hit play when you're ready and see if it works out the same. Now the way I do it might be a little different than you do, but as long as you're getting the same answer as me, that's okay. So pause here and then hit play when you're ready. All right. So the way I would set this up, I'm going to do left, we'll call this left over right. So I'm going to do x over 10 for mine. And if I'm going to be consistent, I have to do left over right on the bottom. So mine's going to be x over 10 equals 4 over 8. And again, maybe you did x over 4 equals 10 over 8. That's okay as well. You're going to get the same answer we do, just a different route. Okay. Now, easy way I see in my head, there's some mental math I can do to get from 8 to 4, divide by 2. Well, if I'm going to do it on that side of the fraction, got to do the same thing on the other. So 10 divided by 2, I know I should get 5. Okay, now I'll show the cross multiplying way as well in case you did that way. But again, should be getting the same answers. So we have 8x equals 40. Divide both sides by 8. Pretty quick and easy math with that. Get 5 for our answer. And let's check. Sweet. So it was 5. All right, moving on to the second one then. So I'm going to do, let's go with top over bottom. And make sure we're consistent on the other side. Top over bottom. And again, more than likely your fraction might have been a little different than mine, but don't go crazy and erase everything. Just wait and see if you get the same answer I do. Okay, now this one, I don't really see an easy way to multiply in my head, so I'm just going to cross multiply. Make sure to write out your work. Don't just try and do it all in your head. You're probably going to miss some easy steps. 16 times y is just 16y. 12 times 20 gets me the 240. If I want to get y by itself, I need to divide by 16. Type that in to double check. And I get 15. Hopefully that's what you got as well. Looks like that's the right answer. Awesome. Feel free to pause here. Go back if you need to. Make sure you really understand this section because proportions are a super important thing for us to know, especially going ahead. We use it a lot and you'll continue to use it in other math classes. All right, so this one is just basically doing the inverse. It's actually called the converse of the triangle proportionality theorem. If you look back at our first slide, it said if a line parallel to one side of a triangle intersects, then it divides it proportionally. Lots of big blah blah words. But really all the converse is doing is flipping that around. So instead of saying if it's parallel, it divides it proportionally, now it's saying if it divides it proportionally, it must be parallel. Okay? So kind of like if I said if it's raining outside, I'm going to need a rain jacket. Very similar to if I said, if I need a rain jacket, it's probably raining outside. Okay, so same kind of statement, just flipping it back and forth. So I believe you've got 3 things to fill in there. Again, we've got our parallel symbol down here. Make sure you know that that means parallel. If not, might want to write yourself a little note off to the side. Wouldn't be a bad idea. And you'll notice in this picture there's no arrows because we're trying to prove if they're parallel this time. It's not given to us. We're not solving for x, we're not solving for y. We're trying to prove, are they actually parallel? Okay, so that means our final answer should either be yes, they are parallel, or no, they are not parallel. There's no x or y. Like I said, you're not going to have variables every time. So don't let that throw you off just because you don't have an empty space. Okay, so I'm going to set it up as top over bottom. And, oops, my line got a little crazy there. Top over bottom. So I'm going to do 9 over 6 equals 12 over 8. Okay, now actually there's a couple ways you can tackle this. One is our cross multiplying way. Oh, oops, apparently I can't write very well with this. Cross multiply. Alright, so if I circle my two ways, 9 times 8 gets me 72. And on the other side, 12 times 6 also gets me 72. Awesome. Since they equal each other, that tells me that we're good. We're proportional, therefore we're parallel. All right, so that's one of the ways you can go about doing it. Second way I can think of, maybe you thought of it in your head, is you can reduce. Just simplify the fractions. If they simplify to the same answer, awesome. That means it's also proportional. Well, 9 over 6, I can divide both of those by 3. So I get 3 over 2. And 12 and 8, I can divide both of those by 4. So 12 divided by 4, oopsies, is 3. And 8 divided by 4 is 2. Awesome, I get the same reduced fraction. Again, tells me it's parallel, it's proportional. Other route you can take is you can actually, give myself a little space, you can divide, kind of like how we did with scale factor. So if I do 9 divided by 6, because it's a fraction, fraction means divide, that gives me 1.5. If I do 12 divided by 8, check and make sure, that gives me the same fraction. Awesome. Okay, so no matter what, my final answer is yes. They are parallel. Okay, again, if you need to go back, pause, write down that stuff, that's fine. But pause here, try these two problems on your own. You should be able to do them without my help, and then press play. Make sure you get the correct answers before you move on to the practice. Alright, so let's take a look at the first one. Now I do want to point out something important with this actually. If I do 10 over the whole, and I do 9 over the whole, which is 9 plus 12, 21, that's still okay to do. You don't have to do part versus part equals part versus part. You can do part over whole, you can do area in these formulas. It doesn't matter as long as you're keeping it consistent. So remember that, kind of keep it in the back of your mind as you start tackling the homework after this, because there is going to be one where it's a little bit different. It's not just going to be part versus part the whole time. So I'm actually going to solve this one this way. Why not? Okay, so I did 10 over the entire side, which is 10 plus 16, and 9 over the entire side. So let's multiply those out. 10 times 21 is 210. Okay, and then 5, carry the 4, 5, 18 plus 5. Alright, so those numbers do not equal each other. So this is not parallel. Okay, pretty easy to figure that one out. This one I'm going to do 24 over 21. Why not? We'll do top over bottom for that one. 32 over 28. I'm going to cross multiply for mine. Do the math. I get 672 equals 672. Awesome. That means that these guys are parallel. Homework is evens only.